Hey everybody. I'm gonna say we're munching a little bit of ice cream. If you're watching this, welcome. It's time to practice some more math. I'm trying to keep it down. It's pretty late. It's been a packed day, but we out here. Let's get it. Before we get started, never underestimate the power of the grind. Go out there and get your work in. That's how you see results, people. Remember, if you need help with any of this stuff, come on by and see us. Come on through during PE. Ask your teachers if you need to. Come on, put in the practice, because that's where all the gains are at. This is a part 2 to direct variations that we looked at the other day. And if you have not had a look at that video yet, you need to see that video first, because this just picks up where we left off. We're going to start with a warm-up to kind of remind you what we did in the last video. Please, if you were looking for just direct variations, go see the part 1, as this part 2 won't make a whole lot of sense if you haven't had some good time in the foundations, okay? Without further ado, let's get started. Hopefully from before you remember that we talked about the concept of y equals kx, okay? Where we talked about k being some number that always shows up in front of x. And because this whole thing is something we called a lonely equation, meaning there is no plus or minus or anything else next to the kx, where k is whatever number is in front of x, then you're good to go, okay? That is called a direct variation. And what that really means is the first letter, in this case y, is varying directly with the second letter, in this case x. And all that means is it is completely dependent on each other. When x is 0, y is 0. And it is linear because the x has no exponent on it, okay? So let's have a look at these and see which one is not a direct variation. I want you to go ahead and try and answer number 1 and 2. Pause me here and try to answer it. In a minute, I'm going to give you the answer. Okay, if you haven't paused me yet, you need to go ahead and do so. All right, here we go. I'm going to go from D on up to A. D is a direct variation. It does not have a plus or minus next to it, and when x is 0, y is 0. It's good to go. C does not have a plus or minus or anything else with the number x, and when x is 0, y is 0. So it's good to go. Same thing for this one. There's no plus or minus anything out next to the number x, and when x is 0, y is 0. Uh-oh. Plus 1. There's no way this can be a direct variation. Why? Because when x is 0, y is not 0. It's something else. In this case, it would be 1. That's not a direct variation. So your answer should be A, because it's asking for what is not an example. Okay? For your next one, let's get started. This one's good. I like this one a lot. All right. Ask yourself for A. If x is 0, is y 0? Yes, that's true. And is there anything out here next to the x? That would be a no. This is a direct variation. It's good to go. If that threw you off, it's okay. Kind of threw me for a second too. I was like, wait, what? Huh? Because we're so used to seeing some number in front of x. Bonus points if you realized that the number in front of x in this case is 1. So if you were to find the k of this one, it should be 1. If that didn't make any sense to you, go back and see part 1, okay? All right, fine. Let's keep going. For this, you need to put it in y equals mx plus b form first. So let's do that real quick. I'm going to do that by getting 2x on the right side. By eliminating it off the left, we end up with 3y equals negative 2x plus 0. Therefore, 3y, here, let me 3y equals negative 2x plus 0. And let's go ahead and simplify that to 3y equals negative 2x, okay? Because 2x plus 0 and 2x are the same thing. Now, let's get y alone. Let's divide it by 3 to both sides, and we end up with negative 2/3 x. All right, you know the question we're going to ask. If x is 0, is y 0? The answer is yes. And is there anything else out here next to that x? No, sir. Some of you might look at it and be like, but Mike, it was plus 0. But plus 0 is technically to anything. So when you get a plus 0, there's no point even writing it. I only wrote it to show you the work. In this case, x equals 0, y equals 0, and this is a straight line, meaning when you graph it, it will go through 0, 0. This is a direct variation, and it is good to go. Okay? For this next one, it should be pretty obvious because this one was so much harder. This is a direct variation. When x is 0, y is 0, and there's no plus or minus anything out there. So, good test strategy. By process of elimination, this would have to be it, but let's prove it. Let's prove it, okay? Let's go ahead and get it in y equals mx plus b form. Let's subtract 5x from both sides to get rid of that so that we're left with just y on the left side. Now that we're left with just y on the left side, we can go ahead and divide by 6. So we're in true mx plus b form. Okay, if some of you are wondering how I got that fraction, negative 5x divided by 6, you can't finish that, so you just leave it negative 5/6. And remember, when you divide two sides of an equation, you have to divide everything. So I can't just do 5x divided by 6. I have to do 5x divided by 6. And I can divide 30 by 6 also. 30 divided by 6 is 5, and it's positive. That's where it came from. Now let's have a look at it to see if it's direct. There's a plus 5 out there. That's going to be a no, because when x is 0, y is not 0. So this is not the direct one, therefore it's our answer. Okay? Hopefully that all makes sense. If not, go back to the first video to make more sense. Now, for this one, y'all know how to find k, hopefully, from the first video. The formula is y equals kx, where k is the amount that our variables are increasing or changing by. And it is a constant amount. It is also called the constant of proportionality. We can call it constant variations here. Go ahead and find that k. Pause me here. Okay? If you haven't found it yet, pause me here so you have a chance to work it. Remember, working is where all the strength comes from. All right, here we go. For this first one, k should equal 5. For the second one, k equals 1/2. For the third one, k equals negative 2/3. Those are so easy. It's literally just a number in front of x. The catch, though, is make sure that the thing that you're supposedly finding a k for, you can actually find a k for. Because if you had something like this, and they said find k, and you said, oh, it's 5. No, it's not. These two variables are not directly related, so you have no k there. Okay? And here's another trick one. Let me write no k on there. And if you had something like this, again, there is no k for this one, at least not a constant of proportionality. You're going to run into this concept hk again later, but it's not today. For now, for our purposes, y equals kx, there is no k here for our purposes. Okay? All right, let's move on. Now this one is interesting. is asking you to write a direct variation equation, okay? Let's have a look at how to do this. Remember that for a direct variation, first of all, it would have to be in this form, y equals kx, okay? So we're not going to have any plus anything, we're not going to have any minus anything. The other thing to remember is that this number k, right here, this bad boy, okay? This bad boy right here should be the amount that this equation is changing by, and that amount is the same. So think about y equals 5x. If x equals 1, then y equals 5. If x equals 2, then y equals 10. If x equals 3, y equals 15. It's increasing by the same amount. And that if x equals 0, y equals 0. So it's always going up by 5. Every time x changes by 1, y changes by 5. Okay? The amount that it's going up is constant. That's why it's called the constant, the k constant. So when it asks us to write an equation, the first thing we need to sniff out is how much y is changing by every time we change x. Here's how you can figure that out. Simply divide y by x, and that will give you the k, because the k tells you how much y changes every time x changes. So all you have to do is divide y by x. That will tell you how much it's changing. Another way to look at this is look at the formula y equals kx. If you need to solve for k, simply divide both sides by x, and you end up with y divided by x. Let me correct that so you don't get confused. Equals k. Now, if that's too much to look at it like this over here, then don't worry about it. The key takeaway is divide y by x, and that will give you the k, because you're trying to find how much y changes every time x changes. So you divide them. So let's take our y, which is 16, and divide it by our x, which is 8. 16 divided by 8 is 2. Therefore, our 2 equals k. Now, are we done? That would be a no. They asked us to write an equation. So let's put it in an equation then. Y equals 2x. This is our equation. We know that's true because if we put in 8 into this equation, we get 16. Because 2 times 8 is 16. Now, technically, we're not done with this. You know why? They did not ask us for just the equation. They asked us to find y when x equals 16. Well, that's no problem, though, because our equation is right, and we checked our equation, so we know it's right. Y equals 2 times 16. Therefore, y equals 32. Piece of cake. Okay? Let's move on to the next. Now, I'm going to work this next one here with you. Again, don't sit here and watch me work things. Pause me and work it. I'm going to work one more with you, and then I want you all to pause me and work the next two by yourself, okay? All right, here we go. The formula for this is y equals kx. All right? Now, actually here, I'm going to leave this one for you because you need to see this down here. They said v and g. Don't be intimidated by the letters. It doesn't matter what letters you use. What you're trying to find out is how much the first one varies directly as the second one. So you could argue that the formula for this one would be v equals kg. Why? Because y equals kx. We're literally just taking the first thing you see and making it the second thing you see. Nothing has changed. Doesn't matter what letters they use. So I'm going to work number 8 with you. I want you to go back and work 7, and then you work 9. That way you have an example of each. All right. So fine. V equals kg. Therefore, the k is whatever happens when you divide v by g. How do you know that, Mike? Because if I take this and divide it by g on both sides, I'm left with v over g equals k. Ta-da! Okay, but fine. Let's put it in. K equals 36 divided by 4. Therefore, K equals 9. Let's put in an equation. V equals 9G. Mike, how'd you get that? I'm just copying what we did over here. There you go. See it now? Okay, and we just found K. All right, that's our equation. Now, remember, it didn't ask us just for the equation. We need to solve it. So find V when G equals 11. Fine. So V equals 9 times 11. Therefore, V equals 99. Done. These are not bad at all. Don't be thrown by the different letters. Don't be thrown by the wording. Now you try 7 and 9 and 10 on your own. Take a few minutes. Pause me here. I'm going to go ahead and take a bite of this ice cream while you work that. That was delicious. Okay, incoming answers. If you haven't already, go ahead and pause me, because answers are coming. All right, here we go. For your first one, let's start with setting it up. Number 7, y equals, we need to find the k first, right? So let's get our k, and our k is going to be equal to y divided by x. Well, if y is 21 and x is 3, then k equals 21 divided by 3. Therefore, k equals 7. So our equation should be y equals 7x. Now let's find x when y is 42. No problem. 42 equals 7x. Divide both by 7, and you get x equals 6. Or if some of you worked it this way, 6 equals x, which is the same thing as x equals 6. Okay, great job. If you didn't get that, pause it, rewind it, see if you see how to get it, then try to work 9 and 10 before I show you, okay? All right, let's move on to 9. Again, I'm not intimidated by them using different letters. They said A varies directly as B, when they just said Y varying directly as X. No big deal. So then let's write it in that exact way. If we've been saying Y equals KX, then we'll just say instead A equals KB. Mike, how do you know the K goes in front? Because K is just a number, and the number is sitting in front of the second letter, okay? All right, so to find K, we need to divide A by B. And so K is going to be equal to 7 divided by 2, because here's our A, and here's our B. So our formula then is A equals 7 over 2 times B. They would like us to find B. So let's do, we need to put in A. It said A is 21, so 21 is equal to 7 over 2 times B. Don't be intimidated by fractions. If you're not comfortable with them, come see me so I can help you with fractions. But the way we're going to get rid of this fraction is by dividing both sides by its reciprocal, which in this case is 2 sevenths. Now, if you got rid of the fraction in other ways, I'm okay with that. I'm going to take the shorthand way because I want to save time so we can get to more problems. There are more than one way to work this out, so as long as you got the right answer, it doesn't matter to me. Here we go. I'm going to divide this by 7 halves, which is the same as multiplying by the reciprocal, and do that to both sides. And we're going to get B equals 42 over 7, which is B equals 6. Okay, if you got to the fraction part and got thrown, don't worry about it. As long as you got everything right up to what you had to divide the fractions, I'm not worried about it. Come see me so I can help you with fractions. If you got the right answer and you did it some other way, fine, so be it. Sounds good to me, okay? don't mind any of this fraction work down here. The only thing I'm concerned with is that you got this part okay. Come see me if we need to learn how to work fractions, okay? All right, here we go. Last one, y varies directly as x. So we're back to normal, y equals kx. Let's first find the k. K is equal to y divided by x. Therefore, k is going to be equal to 9 divided by 3 halves. Another fraction. Again, if you have struggling with fractions, come and see me. This should be 18 over 3, which is 6. Okay? Now, let's plug it into our formula. Y equals kx. Y equals 6x, because we just found out what k is. And now we know x equals 1. So let's go y equals 6 times 1. Therefore, y equals 6. Done. If that went by kind of fast, then put me on like half speed. All right. Hopefully these should be making pretty good sense. It's not that it's not too cloggy. Okay. If it is, come see me. All right. Now from our last lesson, hopefully you remember that direct variation requires a couple things, and we talked about it in graphs. So go ahead and answer this. If you don't know how to do this, go back and see part 1, because I want you working these 2 problems solely on your own. Pause me here. Give it a shot. Okay. Here we go. Last warning. All right. This first one does not, because it doesn't pass through 0, 0. Not a direct variation. Does this represent? Yes. It passes through 0, 0, and is a straight line. Good job. All right. Finally to the word problems, okay? I needed you to get a head start by just getting your brain warmed up on everything we talked about so far. Okay? If you were stuck on any of that, please go back and see part 1 to get your essentials down, okay? All right, let's go ahead and get started with part 2 here. So when it comes down to word problems, the first thing I want you to notice is that let's have a look at this, because I don't want you to look at the instructions so much as the word problem itself. Notice in word problems, it will tell you that there's something that's happening at a constant rate, whether it be you're getting a certain amount of money over a certain amount of time, or you're getting a certain amount of money per hour. So like, because I just said the same thing twice, right? People talk about you making $15 per hour. That is a rate. They can talk about you going 20 miles per second. That's another rate. They can talk about you growing 6 inches, per, I don't know, Jolly Rancher. Like, it doesn't matter. When people are talking about the rate, the amount of something you do per something else, the amount of dollars you make per candy, it doesn't matter, because it doesn't always have to be time, okay? What you're looking for is this right here, because this is your K. Okay? K, remember, is how much you're changing per time, or per whatever. The catch is they don't always tell you straight up. For example, in this problem, it says the restaurant makes $9,000 in 4 hours. Okay? Your rate isn't going to look like this. That's not complete. That's how you're going to get the rate. You're going to divide 9,000 by 4. Why? Because you want to figure out how much you're making each hour. So when you do a rate, it is best when you can, sometimes you can't help it, but when you can, it's best to simplify whatever fraction you end up with, or division problem. Division problems and fractions are the same thing. It's best to simplify it as much as you can. So let's do that. Let's take 9,000 and divide it by 4, and we should end up with 2250. This 2250 is exactly how many dollars they're making for each 1 hour. And you know that because if you take 4 hours, you end up right back at 9,000. So they're making 2,250 every hour. I wouldn't mind making that either. Bring it on. I'm ready. I wouldn't mind making it happily, easily, and sometimes without even meaning to. It just happens. Let's do it. So fine. Let's have a look at, I don't want you to look at that. Let's have a look at another one here. Because I want you to look at that example. It's too worked out for us. That doesn't help us at all. Let's have a look at this. Your distance from lightning varies directly with the time it takes you to hear thunder. Okay? Remember earlier we saw this wording. Suppose A varies directly as B, V directly as G, Y directly as X. When you see something directly as something else, I want you to go ahead and write that down. Let's write down the original equation first. Y equals kx. Y varies directly as x. Okay? So instead, I'm going to call, you can call this just y. You don't have to use different letters. I don't want you to have to learn more than you have to. So let's call lightning y because it says lightning varies directly as with the time, as, same thing. And let's call this x. How? Because it's saying lightning varies directly with the time. So we're going to call that x. Okay? So whatever the distance from lightning is our y. Because that's what's varying directly with the next thing. And the next thing that we're varying directly with is x. So we'll call that x, which is the time it takes you to hear thunder. Fine. If you hear thunder 10 seconds, now which one? Stop right there. I tell people when you're reading word problems, freeze every time you see information. You hear thunder 10 seconds. This is how long it took you to hear thunder. Which of these letters represents the time it took you to hear thunder? Is it distance from lightning? No. Is it the time it takes you to hear thunder? Yes. So x then has to be 10. X equals 10. Okay? Because we said your distance from lightning varies directly with the time it takes you to hear thunder. And remember, when you see that wording, it's the same thing. Y varies directly as x. Therefore, distance from lightning varies directly with time to hear thunder. Y varies directly as x. The time it takes you to hear thunder must be x. And they just told us that. 10 seconds. If that was too much, rewind it and look it over. For those of you who got it and it's like, oh my God, Mike, you're repeating yourself. Good. Repeating yourself is a good way to make things stick and to learn. Okay? That's on purpose. Fine. So x equals 10. After you see the lightning, blah, blah, blah. You are about 2 miles from the lightning. Which one of these is the distance from lightning? Y. So y then must be 2. Mike, you got scribbles all over the place. Okay, I'll clean it up. There you go. 2 has to be the y. Because that's the distance from lightning. So now we have everything we need. Let's build our equation. We've got the y, we've got the x. We don't know k yet, but we'll get to that. Y equals 2x. Or sorry, not 2x. Sorry. Y equals kx. Therefore, 2 equals k times 10. Let's figure out what k is. K equals 2 divided by 10. Let's simplify that. Therefore, k equals 1/5. Okay, if you're uncomfortable with fractions, come see me because we can't spend any time looking at fractions. All right, So k equals 1/5. Is that our equation? No, we need to put that k in here to get our equation. So y equals 1/5 x. Now, Mike, why'd you put letters back in there? I thought we were turning y and x into numbers. It's asking for us for an equation here. And remember, those numbers only mattered for this one example. This equation will take you through any example, not just this one. Okay? That's the value in equations. We used this example to figure out k, because remember, k is the amount that is increasing by no matter what. So we can use this one example to figure out what any example would increase by. And we do that by building the equation using the k from this example. Okay? If that last part was confusing, don't worry about it. If you understood the math, it's all good. You don't necessarily have to understand the whole thing. But if you can get the understanding, do. For in all thy getting, get understanding. All right, now, let's estimate how many seconds it would take. First of all, is seconds y or x? Looks like seconds is right here. It is the time. Mike, you have scribbles all over the place. I know. X is the time. So what we really need to find is x. Okay? And the distance we already said was miles. So I'm going to just put equals y there. When you work word problems, label it just like I am. Do not look at mine and be like, oh, he's just labeling it to teach us. No. You need to label your word problems when you work them too. How you work word problems is quite similar to how you teach it. Okay? Label your stuff. Now, we just said y equals 4, so I'm going to put that into our equation. So 4 equals 1/5 times x. And we need to find x. So let's multiply both by 5. If you don't understand why, take a look at fractions. And that should leave us with x over here equals 20. Now let's prove that our statement is true. Let's put this back in. Y equals 1/5 x. And if x is 20, then y must be 20 divided by 5, which is 4. And ta-da! We ended up right back in the same place we started. So this must be correct. Y equals 4. Okay? Now you try for number 14. And again, if you need to, go back and look at the example we just did. But take a minute to pause me and give this a shot. Okay, if you have not paused me yet, now is a great time. Incoming answer, final warning. All right, here we go. First thing we need to do is, again, I recommend you write y equals kx and write the phrase y varies directly as x. Okay, that way you can see what is going where. Again, I'm not going to teach you to change letters because I don't want you trying to absorb too much in one go. You still got to do parallel and perpendicular lines too. I don't want you trying to juggle the concepts of changing letters and X, Y, Z, and blah, 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 blah. Just try to keep it simple, okay? All right, so fine. Not all in one go. So y equals kx, y varies directly as x. Fine. So then, a recipe for 2 dozen corn muffins calls for 3 cups of flour. The number of muffins varies directly with the amount of flour you use. Well, now isn't that curious? So then the number of muffins varies directly. Look at that phrase. Y varies directly as x. What came before the word varies directly? Number of muffins. What came before varies directly in our original? Y. Therefore, the number of muffins is equal to y. Okay? Directly with the amount of flour you use. So then this must be x. Okay? So, let's rewrite that down here so that we can keep up with it. Amount of flour equals x. And the number of muffins equals y. Okay? Now, let's go back and see how much we have of this stuff. This says we have 2 dozen corn muffins. Therefore, y equals 2. How do you know that, Mike? Because it says number of muffins. And there are the muffins, dudes. Okay? Now, notice this says 2 dozen corn muffins. Some things will play with you and say like number of muffins instead of number of dozens. Oh, look at this. It's playing with us right now. So I don't like word problems like this, starting off like this, because it's just too much in one go, but fine. If it said 2 dozen muffins, then how many muffins do you actually have? Not 2, but 24. Okay? Again, just if you understood that y is going to be whatever this is, then you're good to go. The fact, if you wrote 2 on accident and worked it as 2, I wouldn't be mad at you, because you already grabbed the concept, what goes where, which is more important than noticing that small nuance on your first lesson, okay? But fine. So it's 24, not because there's a 24 here, but because it says 2 dozen. So again, don't be mad at yourself if you didn't see that. If you saw 2 and knew it was 2, that's good enough for me for today, okay? Fine. Amount of flour is equal to x, and the amount of flour is 3. All right? Now we're ready to start solving stuff. Let's first set up our equation, y equals kx, and let's find our k. Y is equal to 24. K we don't know yet, and x is equal to 3. Let's solve for k. K is equal to 24 divided by 3. Therefore, k is equal to 8. Let's make our equation. Y equals 8x. But Mike, why aren't you making y and x numbers again? Because remember, we're building an equation. And when we build equations, we use specific examples because the example will tell us the constant rate. And we can use that constant rate to figure out any example, not just this one. Y equals 8x is our equation for this. So now, let's go and estimate how many cups of flour are needed to make 6 dozen muffins. First of all, let's see who is who. The number of muffins is y. So y is equal to 6. Psych, it says 6 dozen. So 6 times 12. So it's 72. Okay. Again, in some word problems, you have to read what they're talking about and then go for it. Sometimes they'll be straightforward. Sometimes they won't. It just depends on the word problem. Okay. But if you notice that y should be 6, and if it's 6 times something, 6 divided by something, you'll know it by the units, okay? But if you notice it was 6, that is good. That's a good start, okay? Just pay attention to units so you know what to do. So y is equal to 72. We're trying to find x because we're trying to find the amount of flour. So let's go x equals question mark, and k is equal to 8. We already know that. So y equals, so let's put our information in. 72, I got that from right here, equals 8 times x. And so let's divide both sides by 8 to get x alone. And we end up with x equals 9. Therefore, the cups of flour is 9 cups of flour. Okay? All right, I know that's kind of fast, but hopefully that kind of shows you some ways to apply this stuff on your own. And if any of it was confusing, come see us. Work some of your worksheets that you have there at the school. Again, come see us if you need extra help, and we can practice some more practice problems. But rewind this video and see if you can at least understand like where everything was going. But most importantly, then immediately work some more problems. Work problems. That's where you get all the skill, okay? All right, this video is approaching 40 minutes, so I'm going to go ahead and cut it here. If you've worked this far, congratulations to you. Putting in the work is how you get results, okay? Let me know if this is helpful to you in the comments. Let your teacher know, or come by and let me know. And again, if you need help from us, come on with it. We can pick you up from PE, get a pass from your teacher, or get a pass from an elected teacher. If you're in the elected building, get a pass straight from us, okay? Alrighty, we will see you then. Have a good night. And on our next video, we will talk about transformations and parallel and perpendicular lines. I will likely do those in separate videos, so be on the lookout over the next day, okay? Until then, keep working hard and insert cool exit